In this tutorial, you will learn how to implement infinite loading with ReactQuery, both with a load more button and also infinite scrolling, like you know it from social media, where you scroll to the bottom of a page and it automatically loads the next page. You will also learn how to add new items to your infinite list by updating the cache directly, so that you don't have to refetch the whole list, which is very slow. We will use React and Next.js, but you can use this together with any backend, for example Node.js. And I will also provide a starting code project so that you can follow along step by step. The only prerequisite is that you know the basics of React. Welcome to Coding and Flow. I'm Florian Walter and I make web dev tutorials that cut the fluff and get straight to the point. If you want to learn at high speed, subscribe to the channel. The link to the starting code will be in the video description. You can go to this GitHub repository, clone it, and I will add another branch that will be called starting point. You can check out this branch where I already prepared some code and you can use this to follow along step by step with this tutorial. Clone this project onto your computer, open it in your IDE, and then we have to run npmi, short for install, to install the packages. Because I already added some packages to the package.json file. And with npmi we install them, but I will also show you how to set up ReactQuery and install the packages in a few minutes. Again, this is a Next.js project, because in order to fetch data we need a backend, but you can use this together with any backend, also Node.js or something completely different. Let's open the command line again and run npm run dev to run this site in development mode. Then we can open localhost 3000 and click on this button, which brings us to the comments page. There's an input field and this text, but we don't load any comments yet. This is what we want to implement. For this I created some dummy data and a fake database. Let me walk you through it quickly. So we have a data.ts file under app/api/comments, and in here are just a bunch of comments, as you can see. Each of them have an ID, user data, text, and a created at timestamp. Usually this would be stored in your database, but here we created a fake database with this dummy data. And we also have a db.ts file. I wrote this file myself, and this mimics an ORM like Prisma or Drizzle, which you would use in a real app to access your database. You don't have to understand any of the code in here, because this stuff is usually hidden from you. This is usually coming from a library like Prisma or Drizzle, and this is just an object that contains two functions: find comments that we later use to load comments, and create comments to post a new comment. You can check out this file if you want, but again you don't have to understand it, because usually you wouldn't write this yourself. The same goes for the auth.ts file, which mimics an authentication library. Here I created this getCurrentUser function, which just waits for 300 milliseconds to simulate a network delay, and then it returns this fake user with a name and this avatar, which is also just the initials of the user. And again, this would usually come from a library like Clerk or NextAuth or whatever you use for authentication. But for this project, I set up this dummy function, and then I also prepared some components and this empty page user earlier. But everything that's related to ReactQuery we will implement ourselves to learn this. Okay, so in the starting code are already the dependencies for ReactQuery and also the React intersection observer that we will need for infinite scrolling later. If you build your own project, of course you have to install these packages yourself. In this case, you can open the command line, run npm install or npmi, and then add these packages here. So we have to npm install 10-stack ReactQuery, 10-stack ReactQueryDevtools, and also this intersection observer. Add them here, execute this command, and this will add these packages to the package.json. But again, in the starting code I already added them, and we installed them in the beginning with npmi. The next step is to set up ReactQuery, and of course ReactQuery has documentation. They are quite elaborate, and in here you can find the installation instructions, a quick start guide, and so on, but I will walk you through it step by step. The first step is to create a context provider that makes the query cache available throughout our whole app. Sounds very complicated, but it's easy. For this, let's create a new folder in src. We right click on src, create a new file, not folder but file, and we write providers / this way we create a folder, and in here we put the React query QueryClientProvider.tsx file. It's a React component. At the top of the file we add useClient because we are using Next.js and we have to make this a client component. And then we export a default function with the same name, which takes one prop, and that's the children, which is of type React.ReactNode. And the children are all the subcomponents that we want to render within this React Query Provider, which will be our whole app, because this provider will wrap our whole app. This is a so-called context provider. If you don't know what that is, I have videos on that too on my channel. Just search for Coding and Flow React Context Provider. In here we need a query client, and we put this into a state. So we wrap this into square brackets. We call it query client, and we assign this to a use state, to which we pass an initializer function, which initializes a new query client. Looks like I have to import this manually. Import destructure from at 10 stack React query, and in here we should find the query client. There we go. We initialize this here, parentheses. The reason we wrap this into a use state is because we only ever want to have one single instance of the query client, because this contains the cache of React Query and we want to share the same cached data throughout our whole app. We don't want to have multiple query clients. And if we would just initialize it in the function body directly, it would create a new query client on every re-render, which of course we don't want. So we wrap this into a state, and then we return a query client provider like this, to which we have to pass the query client. We close this, and in here we put the children, which again is our whole app. And that's basically it for the React Query setup. There's one more thing we can add directly below the children, and that's the React Query DevTools. Looks like I have to import this manually again. Import from add React Query DevTools. And in here we should find an object with the same name, ReactQueryDevtools, which I want to put here, and we set initial is open to false. These DevTools are really cool. They are a debugging tool for development, and they allow us to open the React Query cache and look in there directly. This is really useful for learning purposes and also to debug your app. We will take a look at this in a moment. Next, we have to wrap our whole app with the React Query Provider. And this depends on what React framework you're using. If you use something like Vite, then you will have an app.ts file that represents your whole app. And you have to go into the app.ts file and wrap all your pages into the React Query Provider. In Next.js, we have this root layout tsx file instead, and this one wraps our whole app. So we go inside the body tag in the example project, and we wrap everything in here into the React Query Provider. The children and the toaster doesn't really matter, can be inside or outside, because this doesn't have to access the React Query cache, but it doesn't hurt to put it inside the provider. Yeah, and that's it for the setup, and now we can start using this amazing library. So as I explained in the beginning, we have dummy data and we have this fake database and fake authentication library. What I didn't set up yet is the server endpoint to fetch our comments, because this is the stuff you have to understand. Again, you can use any backend framework. We use Next.js here, where we can create API routes. And we want to create one under /API comments. And in here we put a route TS file, which creates a backend route. We export in async function. Important, this must not be the default export, otherwise this will not work. And the name of the function has to be get in all uppercase. This creates the get backend endpoint in Next.js. And here we will receive the request, which is of type next request, which should add this import here. So the way infinite loading works is that we load our data here in pages. So we load 10 items, for example, if our page size is 10. But then we also return a cursor, and the cursor is the ID of the next item, so that we know where we have to start the next page. This cursor will be managed and sent by React Query, but we still have to write the backend logic to return this data and the cursor. And you usually have to do this part yourself. So on this backend route, we want to receive the cursor via a search param when we make the request to the backend. So we create a const cursor param, and this part will differ depending on the backend framework you're using, but the concepts are the same. In Next.js, we can get this from the request .nextURL.searchParams.get and the name of the search param, which will be cursor. We will use the same name later on the front end when we make the request. And since our IDs are numbers, but search params are strings, we also have to pass this value. So we create a const cursor. The cursor can also be a string, by the way, depending on your database structure. If the IDs are strings, then you don't have to pass the cursor because then it will be a string. So this one, we want to assign to a cursor param, question mark, we check if this is defined because it can be null if we don't pass the search param, which will be the case when we fetch the very first page. So if it's defined, we call parseInt to pass this to a number. We pass the cursor param, and otherwise it will be undefined. Then we create a const page size for readability and we set this to 10. You can either hard-code the page size on the back end or you can pass it as another search param from the front end, whatever you prefer. If you want to keep your pagination flexible, for example because different clients use it and they want to fetch different page sizes, you can pass this as a param. But here I hard-code it. Then I want to simulate a little delay because here we are not accessing a real database, we just fetch from this array. But when you use a real database, it will take a few hundred milliseconds usually. So what we do is we create a random delay with math.floor, and to it we pass math.random, which we call, times 700, and outside of the parentheses plus 300. This will create a random number between 300 milliseconds and 1 second. Of course, in a real app you would not add this to your backend code. This is just to simulate a loading delay from our database. And then below we call await new promise, to which we pass a function, which gets this resolve argument. Just follow along, you don't have to understand this because usually you wouldn't do this. Then we call setTimeout like this. And to it we pass resolve and delay. This will create a new promise that waits for our delay. And we await this promise here to await this random delay that we created. And now it's time to fetch the comments from our database. So again, I set up this fake database, which exports this myORM variable. So below we create a const comments equals await myORM dot find comments, parentheses, curly braces, and here we pass a bunch of arguments. We pass take. How many items do we want to return? We want to return page size plus 1. Why plus 1? Because this additional item will be our cursor. Then the find comment function takes a cursor. That's the item that we want to start our page at, which is either the cursor that we pass or undefined if we want to load the first page. So again, we check if cursor is defined. In this case, we pass an object, which sets the ID to cursor, otherwise it will be undefined. So this way, our database can decide if it should start loading at this ID or not. If we pass undefined, it will start loading at the first page. And this looks very similar to what we would do with a real database library like Prisma or Drizzle. Actually, we can take a look at one of my projects here that I built for YouTube. That's the code for my social media app tutorial, where we use Prisma to access our database. And here you can see that we fetch a list of posts, and this function looks very similar, but this is real production code. We have Prisma, which is our ORM, posts.findMany, and then we have this take value that we also passed a minute ago. And here we pass the cursor. So this looks very similar, and we can also order the items, which we can also do in our fake ORM with the sort prop, and we want to sort them in descending order, which sorts them by the timestamp. So this looks very similar to real production code. You just have to adapt this to your ORM. Okay, almost done. So now we have our comments with this one additional comment, which is the cursor. So next we create a const next cursor to extract this cursor. And here we check if comments.length is greater than the page size. This means we have this one additional item. If it's not greater than the page size, it means there was no additional item, which means that we reached the end of our pagination, right? Because if we fetch the last page, for example, from 41 to 50, we don't have this one additional item below because we are at the end of our list. And this way we know that we don't have a next cursor. So only if the returned data.length is greater than the page size, we have a next cursor, which will be at comments, square brackets, page size, so the last item, .id. The ID is the cursor. And if the length is not greater, then again the next cursor is undefined. There is no next cursor. Next we want to create a response body, which is what we return from this endpoint, and then we are done. But I actually want to create a type for this so that we get type safety here. We can put it into the same file above, or you can put it into a separate file called types.ts, for example. We also export this type here so that we can use it in other files later. Export type, let's call it getCommentsResponse. The name of this is up to you, doesn't matter. In here will be an array of comments. Make sure to import the comment type from the data folder, because there's also a comment type available if we don't import anything, but then your app won't work because the type is wrong. So this is an array of comments, and in here will also be the next cursor, but we add a question mark because this one is optional. We might not have a next cursor, right? And then our response will be of this type getCommentResponse, and then we get autocomplete and type safety in here. So the comments are the ones we returned, but remember we have this one additional item which is the cursor, but we don't want to show this item on the screen, we only want to show the page size. So here we write comments comments.slice 0, page size, which removes this one additional item. And the second argument is the next cursor. And then finally, we return a next response, which we import from next/server as a JSON response. And in here we put this object we just created to return it on the front end. And that's our backend code. Again, the exact code in here depends on your backend framework and the ORM you're using, but the concepts are the same. You have to pass a cursor to this endpoint. You have to fetch this page with one additional item from your ORM, and the one additional item becomes the next cursor, and we return this from this backend. The next step is to call this endpoint from the front end to render our comments. For this we go into the comments list TSX file that I already prepared, but as you can see there's not much in here yet. And this component is rendered on this comments page together with the comment form, which is what you saw earlier on localhost 3000/comments. And here we want to render our list of comments. So back into the comments list component. And here at the start of the component, we want to use ReactQuery to fetch our comments. So we create and destructure a const, and we assign this to useInfiniteQuery, which is an import from ReactQuery. We call this and add curly braces, and here we have to pass a bunch of different arguments. The first one is the queryKey. This is the key of the cache entry of this list we load here. And if we want to modify this cache or we want to show it in multiple different places, we have to use the same key. And this can be a simple string, comments for example. The second argument is the query function. This is what actually fetches the data from our backend. Now it's important to understand that ReactQuery is not a fetching library. It doesn't do data fetching. It handles the data for us, but we have to fetch it ourselves. And what we use for that is up to us. I installed Kai, which you can find here in the package.json file, which is a fetching library that looks very similar to the native fetch function, but it's much easier to use. You can also use fetch instead or something like Axios, this is up to you. But to the query function, we pass an arrow function, which does the fetching. So here I import Kai to use it. Import Kai from Kai. This is the shortest import statement ever. And on it we can call get to make a get request to our server endpoint. This is the route we set up under /API/comments. This is where we want to make a get request to. So here as a string we pass /API/comments. After .get outside of the parentheses we write .json, which passes the data that we get back. We call this, and here we also have to define the type of the data we get back so that we get type safety in here. Remember, we return a getComments response, and we can use the same type here, getComments response. Now ReactQuery knows the type of data that we get back from this endpoint. But remember, our backend expects the cursor as a search param. This is why I made this a backtick string. In here I want to put a variable. So after /comments we write a question mark. This starts the search params. And then we want to put a variable with $, curly braces. Now the question is, where do we get this cursor from? We get it from ReactQuery because it manages the cursor for us. It will be passed as an argument to the query function. So we go inside the parentheses, add curly braces to destructure this, and in here we should find the page param. The page param is the next cursor, so we can use it here in our URL. But it can be undefined, remember. So we check if page param is defined with a question mark. In this case we want to pass another backtick string. This is a bit nested, but just follow along, make sure to spell this correctly. We want to append this cursor param to the URL with cursor equals, and this has to be the same name as our search param string here, because this is the param we expect on the backend. So same spelling, cursor equals, another variable in here, and in here we want to put the page param, which is the cursor. So our URL points to /API/comments question mark, then it checks if the cursor is defined. If yes, it adds the cursor param. Otherwise, right here, we append an empty string, which means that we don't add the cursor to the URL. Okay, if this looks a bit confusing, just pause the video and type this out letter by letter as I did here. Then we have to pass another argument to useInfiniteQuery after the query function, which is the initialPageParam. This is the first cursor. We have to tell ReactQuery what the first cursor is, but remember, the first cursor will be undefined, because if we pass undefined to our backend, we will start loading at the first page. So to initialPageParam, we pass undefined. The only problem is that ReactQuery uses this value to infer the type of the page param. And undefined is not what we expect number or undefined. But we can fix this by asserting the type manually with asNumber vertical bar undefined. This way ReactQuery knows that the page param is either a number or undefined and not just undefined. But of course you only have to do this in TypeScript. And one more argument we have to pass here, getNextPageParam, which tells ReactQuery how it can find the next cursor. This is also an arrow function where we receive the last page. That's the last fetched page. And here we will get autocomplete. We assign this to last page dot next cursor. We get type safety because this last page is of type getComments response, because this is what we return here. And remember, in here are our comments and the next cursor. And now we give this next cursor to ReactQuery. And this way, it automatically becomes the page param for the next page. Makes sense, right? And now pagination will work. And the only step left is to render this data on our screen. So inside this destructured const here, we find a bunch of different values. We find the data, which are our pages. We find is pending, which will be true before our first page has loaded. We can use this to show a loading state. We have is error, which will be true if there is an error. We have the error value itself. We have this fetch next page function, which I think is self-explaining. Has next page is also a boolean. And one more is fetching next page. We destructure all of these values and then we use them in our UI below. Inside this data are our comments, but this is actually not an array of comments. It's of type InfiniteData, and then here is our getComments response. So this data looks something like this. It's an array, In here are the comments, which are another array. And I think the next cursor, I'm not sure right now. But the point is we have to get our comments out of this in order to render them on the screen, which we do the following way. We create a const comments and we assign it to data.pages. In here are our comments. We call flat map on this. To this we pass an arrow function which receives each page and we return page.comments. So this gets the comments array out of each page, but if we would call just map, this would create a two-dimensional array, an array that contains other arrays. And with flat, we flatten this array. So now we have one array of comments, or undefined if we haven't fetched any comments yet. So I always do exactly this after fetching data with useInfiniteQuery. And then below we can check if is pending. So if it's loading and we haven't loaded the first page yet, this will only be true for the first page. We also have is loading and is fetching, which are different loading values, and you can find what exactly they mean in these documentation comments, for example by hovering over them. Is pending will only be true for the first page. This is why we can use this with an early return, where we want to return a loading state. And here I'm going to use this loader2 icon from Lucid React. You can also render a string that says loading, or a loading skeleton, or whatever you want. This is up to you. And I want to make this rotate with animate spin, and I want to center this on the screen with MX Auto. So this is the loading state. And below we want to render the actual list of comments if is pending is false. So in here we put a div with space y4 to add some spacing between the comments. Remember, comments can be undefined if we haven't loaded any yet. So we check in an expression, curly braces, comments, two ampersand signs, comments.length is greater than 0. So only if comments are defined and there is at least one comment in there, we want to render with two ampersand signs a fragment. Why a fragment? Because here I want to render the list of comments and also a load more button. We will replace this load more button for our infinite scroll trigger later, but for now we will use a button because this is the most simple approach. So if we have at least one comment, we want to render another div in here, like this. With space y3 at this time, but how you style this is up to you. In here one more expression. We take the comments and we map them. This is standard React stuff. We get each comment and we want to render a list item, and for this I already prepared this comment tsx file. This is a component that can render one comment object with its text, the timestamp and the user data. In your app you would write this yourself. So here we render a comment which we import from the same folder, which needs a key. This will be the ID of the comment, and it needs the comment itself, so that we render this on the screen. Below this inner div, still inside the fragment, I want to render the load more button, which we also put into a div for alignment. This div gets flex, justify center and a vertical padding of 4. And in here we want to render the load more button, but only if there is a next page. And for this we have this has next page boolean. How does React Query know if there is a next page? Well, if the next cursor is undefined, then there is no next page, right? This way we can show a load more button only if we actually have a next page, which is really cool. So down here we check has next page, two ampersands, parentheses. In this case we render an uppercase button. When we click this button, we want to fetch the next page. We pass an arrow function, and again we have this function that we destructured from useInfiniteQuery, fetch next page, which does exactly that. So we call this function here, very simple. We also want to disable this button while the next page is already loading. So we set this to is fetching next page, which is also coming from our hook above. and we want to style this button with px4 and py2 just for styling. We close this button, and in here we want to render a text, either load more or loading more to indicate a loading state. So again, in an expression we check is fetching next page. In this case this will say loading more ... Otherwise it will say load more comments. We still have to add an error and an empty state, but for now let's save this and let's open our comments page again. And as soon as we open it, we should start fetching the first page. We should see a loading state for a few moments, and then we should render our list of comments. New comments demo, loading state, and there is the first page and our load more button. And when we click load more, it will fetch the next page. Really cool. Until we reach the last page, and then we won't see this button anymore. There we go, no button, no next page. Celeb Carta is the last item in our data array here. And because we order them by the timestamp, it's the oldest item with the ID 1. We still need an error state, and your first idea might be to add an early return here again that checks if this error is true. And again we return an error message, but I would not recommend this, because what if an error happens when you load the third page, for example? Then this early return would remove all the data that we have already loaded, which is a very jarring user experience. Instead, you usually want to render the error message together with the data that you already have. So we don't add an early return, and instead we put the error message here below our list of comments. So here we check if this error is true, then we want to render our error message, but we also keep rendering the comments that we already have. So let's put another div in here, add a closing tag. We style this div with text center and text red 500. And this will say error loading comments. And we can also render the error message in here. Again, the error is coming from ReactQuery. Let's save this, and to try this out, let's throw an error from our backend route just for testing purposes. So here above where we get the comments from our database, we can return a next response.json. The body will say error colon failed to fetch comments, because of course there can always something go wrong when you fetch data from a backend. And by setting the status to 500, this will indicate an error on the front end. So now we refresh this page after saving this file, and we should get an error message instead. And when we look into the console, we will see that this makes multiple requests, because ReactQuery automatically retries the request a couple of times by default. This is why it takes so long until we see the error message. We can configure this, we can disable it or change the number of retries, but by default I think it does 3 retries. It probably did so many because I refreshed the page. But yeah, now we see the error message, and instead of rendering the error here, you can also just write a generic error message like error loading comments or something went wrong. But I also want to see what happens if we load the first page and then get an error. So I comment this out for a moment, refresh the page to load the first page. And now I want to return the error again. Again, this will do a few attempts. And then eventually we see the error message. But again, we see the error message together with the data that we already have, so that we can just continue trying to load our comments. Let's remove this error again. I'm gonna keep it here as a comment. There is one more state we need to handle in here, and that's the empty state. Because what if there is no error, but we also don't have any comments in our database yet? This can also happen. Then we want to show a message that says there are no comments yet, for example. Let's put this also in here below where we render our comments. We add another expression. First we check if error is false, because the array of comments can also be empty because there was an error, right? But only if the error is false, we know that there are no comments in our database. And if exclamation mark comments.length. So if comments is defined, but the length is 0. Then we want to render another div, which will say no comments yet. And again, I want to style this with text center. Let's try this out as well by making our data array empty for a moment. Save this, refresh the page, and then we see the empty state. Perfect. Let's add these items back in. Now you know how to use useInfiniteQuery, but there are still a few things left to do, like adding infinite scroll or updating our list when we add a new comment, so make sure to watch this video all the way to the end to not miss that. One good practice when you use ReactQuery is to extract this stuff here, useInfiniteQuery together with the configuration, into a custom hook, so that your components don't look so complicated. So what we do is we cut out this part after the equal sign, and put it into a separate file in the comments folder. New file, we can call it use comments hooks, for example, but the name is up to you. From here we export a function called useComments, and in here we simply return what we just cut out. But we have to import the hook, Kai, and a getComments response. We put all of this stuff in here to hide it away neatly. And then instead, in our comments list, we call this hook we just created, useComments. Looks much more organized now, doesn't it? And the cool thing is we can use the same hook in other places. And since these comments are stored in the ReactQuery cache, it will actually use the same cache wherever we use this hook. So if we already have cached data and we also show the comments on another page, then we don't have to wait for them to load again because they are already in the cache. And by the way, this icon down here are the ReactQueryDevtools that we set up earlier. And here we can look into the cache. Here we can find our one cache key, comments. And in here are the pages that we have loaded. Here's this data explorer. We have one page and one pageParams object. The first cursor is null. And when we load another page, we should have 2 pages in our cache. There we go, 2 pages. And each of them contains the comments and the next cursor. This is the data that we returned from our backend, right? 10 comments, the next cursor is 40. Another 10 comments, the next cursor is 30. That's the idea. And in here are the comments itself. And you can actually make changes to this cache directly. You can go in here and change this data, and later we will learn why this is important and how to do it. For infinite scroll, we will use React Intersection Observer, which is a library that wraps the Intersection Observer API. This allows us to detect when a certain element is visible on the screen. And we use this to put a little div at the bottom of our list. And as soon as this div is on the screen, we know that we have to load the next page. And instead of putting this code here directly into our components, which would be very unorganized, I like to put this into a separate component that we can reuse in different places. Let's put this into the components folder here. Right click on components, new file, and let's call it infinite scroll container.tsx. Then we export a default function with the same name, infinite scroll container, and this will take some props. We need an interface for these props, infinite scroll container props. It will take the children because this is a wrapper around other elements. This again is of type react.reactNode, which we used earlier for our context provider. We will pass an onBottomReached callback so that the user of this component can decide what should happen when we scroll to the bottom. This is a simple arrow function. We could also call this loadMore, but I like to keep this name generic because the user of this function should decide what happens when we reach to the bottom. Maybe we don't want to load more, maybe we want to do something else. This is why we keep this name generic by calling it onBottomReached. And then I also want to pass optional class names to style this container. Then we destructure these props here. Infinite scroll container props, and in here we find the children, onBottomReached, and a class name. In here we destructure a const and we call this useInView function from the React intersection observer library. And in here we will find a ref. And we have to assign this ref to the element that we want to check if it's on the screen or not. So below we return a div. In here we render our children. This will be our list of items later. And at the end of this list we put another div with a self-closing tag and we assign this ref to it like this. So now we can check via this useInView hook if this div is visible on the screen or not. And since we render it below our children, it will only be visible if we reach the end of our list. We can also do some configuration here in useInView. I like to add this root margin, which adds a margin around this element so that we start loading not when it's actually on the screen, but a little bit earlier. So we have a little bit of space around it. This creates a better user experience. We set this to a string with a size value, for example 50 pixels. You can play around with this. But a more important argument is this onChange callback, where we get this inViewer boolean, which tells us if this div here is visible on the page or not, including this root margin. And we can remove this entry value because we don't need it. And this is very simple. If inView is true, what do we want to do? We want to call our onBottomReached callback. And then the caller of this container can decide what should happen when we reach the bottom of the list. Very simple, right? Just one more thing, I also want to apply these optional class names here on this div so that we can style this container if we want, like this. And that's it, our infinite scroll container is finished. Next we want to use this on the front end, but instead of modifying this comments list, I want to copy it so that later when you look at the code you can see both examples again. The one with the button and the one with the scroll container. So let's copy paste this component here and call the second one comments list scroll, for example, and rename also this function name. A lot of the code can stay as it is. We still fetch our comments through the useComments hook, and we still have this early return if the comments are still pending, but we remove this whole div that contains the load more button, and we replace this fragment here with our infinite scroll container. So we change it here and also this closing tag down here. And remember, this expects the onBottomReached callback. And we can also remove this inner div here and instead use this class name with space y3 on the infinite scroll container because we passed this class name prop to it. So let's remove this inner div here and render our list of comments directly inside the infinite scroll container. But we still have to implement onBottomReached. And this function now has the same job as our load more button had earlier. It should load the next page. But since this triggers automatically, we have to add a little bit of checks in here. So to it we pass an error function, which checks if hasNextPage is true, because only then we can load a next page. And we also have to check if isFetching, which is another value that I want to destructure from the hook. isFetching will be true when it loads the first page or any other page. So this is not only true for the first page, but for all of them. And we should check if isFetching is false and only then try to load the next page. Otherwise we can get race conditions. This is described in the ReactQuery documentation. So only if we have a next page and we are not already fetching a page, then we want to execute the fetchNextPage function, which then loads the next page. Pretty straightforward, right? Just one more thing. Below our comments list, I also want to render another loading indicator while we are loading the next page. So here we add another expression inside the infinite scroll container at the bottom. Is fetching next page, if this is true. We want to render a another div that we style with flex, justify center and my4. And in here we put another loader2 icon with animate spin. There we go. Just one more thing, on this outer div here, I also want to add a margin bottom of 10 because this looks better when we have this loading state so that we can scroll down a little bit further. We add this margin to the bottom. Okay, let's save this. Then go to the comments page, because here now instead of the comments list, we want to render the comments list scroll. Save this as well, and then let's try this out. Let's refresh the page. We see the is pending state, and as soon as we scroll to the bottom, we will see a loading indicator, and then it should automatically load the next page. Let's try it out. There it is. Boom. Next page. Next page. Isn't this cool? Like on a professional social media website until we reach the last page. Now the next step is to learn how we can update this list and how we can then show the new comment without having to refetch all this data. This is a very important topic. You don't want to miss this, so make sure to watch this video all the way to the end. To add a new comment, we will need another server endpoint where we can send this comment to. And again, this is something you have to set up yourself in your app. You need an endpoint where you can send your data from the front end and then make a database request to add this new comment. Again, here we use our fake database. From the route.ts file that we already have, we export another async function called post in all uppercase, which again receives the request of type next request. And to this endpoint, we will send some data. But this time not in the search params, but in the body of the request, which we can get via await request.json, which we call. And in here we will find the text. This will be the text of the comment that we entered and then sent to our endpoint. Below we check if !text. If it's missing, then we want to return an error response because then we can't insert this comment into our database, right? And we have to take care of this case. So we return a next response.json, where again we return an error message in the body, missing required fields. And again we set an error code, but to 400 this time, which means invalid request. Then again below I want to have a random delay to simulate that we are making a real database request. So let's copy this, paste it here. Then to insert a new comment into our data array here, we will need the current user for our comment, which again is this type. It has a name and an avatar, which are both just strings. Now in a real app, this user data would come from your authentication library. But again, I set up fake authentication via this getCurrentUser function, but this looks very similar to what you would do in a real app. You would fetch the user data, getCurrentUser, via await getCurrentUser. Or sometimes this function is called auth or getSession or getAuth or whatever, but the point is we need an identifier for our user. This can be the ID of the user or the user data, whatever your database model expects. Then below we create a const new comment, and here we call await myORM, which has this create comment function, parentheses curly braces. This expects the text and the user that wrote this comment, which is the current user that you get from your authentication library. And then we just have to return a response, similar to what we did here. Again, I want to set up a type for this, so that we get type saved here. Export type create comment response. And this will contain the comment that we just created. We return this to our front end so that we can put it into the UI later without having to refetch the data, but more on this in a moment. So from this post endpoint, we want to return the comment we just created. Because when you call create on your database, it usually returns the thing you just created, like the comment. This is also how it works with real databases and ORMs like Prisma. And we want to return this new comment to the front end. So we create a const response, which is of type create comment response. And in here we put this one comment that we just created. And finally, we want to return this to the front end via a next response. And that's it for this endpoint. Then we need another function to send this comment to our backend. And for this, we go into our useComments hook file and we create another hook here. Export function, use create comment this time. And here we return useMutation, which is another hook from ReactQuery. useMutation is used whenever you don't want to fetch data, but create or update data. Here we have to pass configuration again. We need the mutation function, which is the operation that we want to execute when we do our mutation, right? To this we pass an error function. And to this error function we pass the new comment, which we destructure to the text, which will be of type string. You can pass anything you want here. We decide what are the arguments that we want to pass here. We can pass a text. We could also pass a title, for example, more value. The only rule you have to follow here is this should be one object. You can't pass multiple different values here. We could not do this text and title separately because the mutation function only takes a single argument. And if you need multiple values, then you have to wrap them into an object like I did here. But here we only need the comment text and nothing else. Then we add the right arrow and then we execute our post request, for which again we use Kai, but you can also use fetch or Axios or anything else that creates data. You could also use a server action in Next.js, by the way. On Kai I call post. Again, here we have to pass the URL that we want to post this to, which again is /API/comments. And the second argument to post is this object where we can define the JSON body that we want to send. And that's the comment that we pass to the mutation function. So we send this to our backend, which then extracts the text from the body right here. That's what we are doing here. But remember, the post endpoint also returns the newly created comment. So we want to get this response here and pass it to the correct type, which again we do via this JSON function, where we set the type to create comment response this time, and then we add parentheses to call this. So now this will make a post request, but also fetch the returned data and return it to the front end. Now one thing to keep in mind is, after we posted the comment, our list will not automatically refetch. We won't see the comment until we either refresh the screen or ReactQuery refetches automatically. If we want to update our comments list after we did our mutation, we have to tell ReactQuery to do so, which we can do via this onSuccess callback function that we can pass here. In here we need a query client, which we create at the top of this hook. Const query client equals use query client. The query client allows you to access this query client in the provider that we created here. And we can use this to do different operations, like telling ReactQuery to invalidate the cache and refetch the data. And this is what we want to do here in onSuccess. QueryClient.invalidateQueries, to which we pass the queryKey, which is the key of the query that we want to revalidate, which is this one. So we have to add the same string as we did up here, comments. Only like this it will invalidate this query up here, which triggers ReactQuery to refetch the latest data. Now there's one big problem with this approach that I will show you in a few minutes, but for now let's save this file and then use it in our comment form that I already set up earlier. Right now this is only an input field with a handle submit function that doesn't do anything. In here we want to call our mutation. First of all, we have to get a reference to the mutation by creating a const mutation, and we call our useCreateComment hook, which we created a moment ago in our hooks file, right? And we call this here. And then here in handle submit, we can call mutation.mutate, which triggers the mutation. To it we have to pass this text that we defined in the mutation function. So we pass an object that expects the text, and this is our comment text input here that we store in state. This is whatever we typed into the input field. Then we pass a second argument to mutate another object, and in here we can do configuration. For example, we can pass the same onSuccess function that we also have in our hook. So we have onSuccess here in mutate, but remember we also have onSuccess in the useMutation hook right here. So what's the difference between these two? They both do the same thing. They execute code when the mutation has finished successfully. Inside useMutation, you should put everything that's closely related to this mutation, no matter on what page you use it. For example, invalidating the query to refetch the latest data. This makes sense to put in here, so we don't have to repeat this in every component. But everything that's closely related to the component itself should be done in here. For example, I want to reset the comment text. We can only do this in here, right? Reset this to an empty string. But also showing toast messages makes sense to do in the component. We could do this here, but it's more related to the UI. So it's better to do it in the component itself. And we can import this toast function from Sonner, call toast.success to show a toast message, which will say comment posted successfully. And similarly to onSuccess, we also have an onError callback, which again is an error function. And here I want to show toast.error just so that we have some feedback. Failed to post comment. Please try again. Nice. Now one question you might have is, why do we wrap our operation into this mutation in the first place? Because after all, we could also call Kai directly here inside this handle submit function, right? There is no real reason apparently to wrap this into useMutation. So what's the purpose of this? Well, one benefit of useMutation is that we get these callbacks, which are useful, but we don't need them. We could also handle this with a try-catch block, right, to handle the success and on error case. But there are some other useful goodies here that are nice to have. For example, we could configure this mutation by giving it a retry to automatically retry this, which is disabled by default for mutations. This is one option. But also this mutation returns different values, like an isError or isPending state or the error itself. This way we don't have to handle our own states, and this is why useMutation is useful, but again it's not mandatory, you don't have to use it. And we can use these states down here. For example, we can disable the input field while the mutation is pending. Similarly, I also want to disable the button either if the input is empty or if the mutation is pending, and I also want to change the text of the button. If mutation is pending, I want this to say posting ... otherwise it will say post. Okay, and now everything should be ready and we should be able to do our mutation. So let's refresh our page just to be sure that the latest code has been applied. And now when I write a new comment, it should be added to the top of the list. And it posted, and a moment later we see the new comment. Okay, really cool. But there's one problem, as I mentioned earlier. First of all, you notice a delay. After I post this comment, it takes a moment until the page has refreshed. But what's even worse, this delay will take longer the more pages we have loaded. Why? Because when we call invalidateQueries on this paginated list, ReactQuery goes ahead and reloads every single page one after another, starting at the first one, then the second one, then the third one, and so on, all the way to the end of the list. And the more pages we have loaded, the longer this will take. So now after loading all pages, if I write another comment, you will notice that it will take several seconds until we see this comment on the screen. Oh, not there, not there. And we have to wait. And now we see number 4. And again, this will take longer the more pages we have loaded, and it's also quite wasteful because we have to make so many requests to our backend, one for each page. This is why I don't like this approach here. It's not very professional. It works nicely for normal queries, but not for paginated lists. Now one thing we can do, which is still pretty bad, is returning invalidateQueries. This returns the promise from this onSuccess function, which has the effect that the mutation will stay in the loading state until the invalidation is finished. So now we keep the loading state here until we have reloaded all our pages, but this doesn't really solve the problem because we still have to wait the same amount of time. The better solution is, as I alluded to earlier, to modify the cache directly. Instead of refetching all the pages, we can take the comment that we get back from our route and put it directly here inside the React query cache. This is a little bit complicated because we have to go in here and update this data, but it's very important to understand this if you want to build a professional infinite loading list. For this, let's go once again into our useCommentsHooks file. The first thing I want to do is, instead of repeating this query key over and over again, which is not great because then we can make typos in here and we will have a bug, let's extract this into a variable outside of our functions here. At the top of the file, const queryKey, it will be of type queryKey from React Query, and we simply assign it to this comments array. And now we can use this here as the query key and also down here to get rid of this duplication. Now actually I want to remove invalidateQueries altogether, so I comment this out. This is just for reference as a reminder that you can do it this way, but it's not optimal. I will leave it in the final code as a comment. Instead we want to update the cache. And remember, from our post function here, from this endpoint, we return the comment that we created. We receive this here, and we also receive this in the onSuccess function. When we destructure this value, we can find a comment in here. This is whatever we return from our mutation function. That's what we get passed here. And we can use this to update our cache. Now there are a bunch of steps involved, and the first time you do this it looks very confusing, but the cool thing is once you have done this one time, you always have a reference to get back to later to remind yourself how this works. The reason why this is complicated is because we don't have a simple array of comments, right? We have this infinite data, which is quite nested, because in here are the params, the pages are an array, and the pages are the comments and the next cursor. So we have to update this similarly to how we would have to update state in React. But I will walk you through this step by step. And all of this happens in this onSuccess function so that we execute it when our post operation has finished. The first step is to call await query client, cancel queries, to which we pass the query key. This again is to avoid race conditions, because when we update our cache, we don't want another refetch to come in and override our changes. So the first step is to always cancel the running query before you modify the cache. And to call await, we make onSuccess an async function. Then we call queryClient setQueryData. This is how we update the cache. Here, first of all, we have to define the type of the data that we want to update so that we get type safety in this function. And whenever you use useInfiniteQuery, the type in here is of type InfiniteData, which is another React query import. Then we make another pair of angled brackets like this. And here we have to define the type of this InfiniteData, which takes two type arguments. The first one is the data that we return from our backend, which is getCommentsResponse. Then we make a comma, and then we have to define the type of the cursor. Remember, this one is number or undefined. So this is the type definition of setQueryData. Then we call this function. To it we have to pass the query key and a function where we can update the cache. And this one receives the old data. We pass an arrow function like this. And then we can update this old data and return the new data, the updated cache. And this old data is of type InfiniteData, getCommentsResponse, because this is the type we set here. I hope this is understandable. And for updating the React query cache, we have the same rules for updating state in React. We must not mutate the state directly. Instead, we have to create a copy of it and return it. So let's think what we want to do. We want to take the new comment and we want to put it at the first position of our infinite loading list, which means that we have to go inside this cache. Inside the first page here, we want to open the first page. So let's start with this. Here in setQueryData, we create a const first page and we can get it from old data.pages. We don't get autocomplete here for some reason, but we want to access the page at the index 0 to get the first page, which is either get comments response, which is one of these pages here, or undefined if we don't have old data yet, if we haven't fetched any pages yet. So below we have to check if first page is defined, and only then we want to modify this first page. So here we have to return the new data, so old data with our modifications, which is a JavaScript object. So data contains pages and page params, right? So we could write page params colon old data.page params, or we can just spread the old data like this. And then pass the pages separately because we want to change the pages, right? Pages is an array. It's this array that you can see right here. And from this array, we want to take the first page and we want to update it, right? So in this pages array, we pass another object, which is the first page. Here we spread the values of the first page, which are the comments and the next cursor. Don't worry, it's not much more code. We are almost done. And what do we want to do? We want to take this comments array here and we want to add our new comment to the first position. So as the second argument in this page object, we pass comments, which is an array. Here we put our new comment first to put it at the first position. And then we spread first page.comments, which are the comments that we already had in the first page earlier. If you want to append this new item to the bottom, then you have to get the last page and add this element at the last position of this last page, right? Okay, this way we modify the pages, but now the pages only contains the first page. We still need the other pages, page 2, 3, and so on. So below this first page here, we spread ... old data.pages, but we remove the first element because that's already this page here, right? So we call slice with the index 1. And that's already it. I hope this was understandable. So we go into the cache, we take the old data, from the old data we take the first page, we modify the first page, put it back into the data and then return the modified data to update our cache. If you want to implement this into your own apps and you need a reminder, you can always take a look into the repository of this tutorial to remind yourself of how this works. Let's save these changes, refresh the page and then try this out. Again, we load all the pages because remember, this caused this long loading delay before we saw our comment. But now we shouldn't have this delay anymore, because instead of refetching all the pages one after another, we take the comment that we return from our post request and we put it into the cache directly. You can still call invalidateQueries afterwards if you want, but it's not really necessary, and frankly it's also wasteful in my opinion, because then we have to refetch all these pages. Okay, let's try this out. Comment number 6, post, and after the mutation has finished, the post request, we immediately see the new comment in the list. And this is exactly what we want. And it doesn't matter how many pages we have fetched previously. Let's also take a look into the QueryDevtools again, because now we should be able to see the new items that we add here. So we have the first page, which already has 12 items instead of the usual 10, because we put these 2 new comments in here. And when I make another comment, it will be 13 items. And now the first element is the comment 8. I hope you enjoyed this video. If you want to see a full tutorial on React Query, I have that on my channel too. There you learn a few more things like optimistic updates or searching with React Query. I also have a free React Best Practices course that you can get under codingandflow.com/reactbestpractices. When you get this course, you automatically sign up for my free email newsletter, which I highly recommend, because there I send web dev tips about once every 1 or 2 weeks. It's not too much, but it's a nice way to stay up to date as a web developer. And of course, you can unsubscribe at any time. Finally, subscribe to the channel if you want to see more tutorials like this, and then I wish you a nice rest of the day. Happy coding, take care.